Welcome to the project demonstration of single phase inverter using PV grid. So photovoltaic cells. So we are providing the input for this 12 volts 1 amp battery charging purpose, and also we are going to convert the 12 volts DC to 230 volts AC based on the H-bridge inverting circuit we are using. So we are using full bridge H-bridge circuits which will get the trigger pulse input from this PIC16F72 microcontroller from C0 C1 pins. So from here we are going to provide the 50 Hz of clock frequency signals to this full bridge MOSFET HB circuit. So here we are using the two types of MOSFETs. One is IRF 540 and another is IRF 9540. These two are the N channel and P channel MOSFETs. So the main purpose of this HB circuit is which will take input of 12 volts DC from this battery circuits, and which will provide us the 12 volts AC of 1 amp. So that will be step up to 230 volts AC with help of this step up transformer, which will take 12 volts 0 to 12 inputs and provide us the 230 volts AC output to this grid section. So in this one we are using two charging circuits, one charging circuit for the PV array and another charging circuit for the AC grid. So as whenever there is no sunlight is available, we can charge this 12 volt 1 amp battery pack with help of 230 volts AC input, and this transformer will step down the 230 volts AC to 12 volts of AC, and that will be converted into 12 volts DC with help of this charging circuit. The output of this charging circuit is 12 volts DC, and here also 12 volts DC. So these both charging circuits look like same. On this one we can observe the 4 diodes which are connected in a manner of bridge rectifier and one capacitor for smoothing purpose after the rectification. When we are providing the AC input from this transformer, these 4 diodes will act as a rectifier to convert the AC to pulsating DC, and capacitor to remove the pulses to make that pulsating DC to smooth DC, and that is the charging voltage for the battery directly. But on this charging circuit, when we are providing the DC input, so these 4 diodes will act as a polarity corrector. Means when we are connecting the DC input, we should take care of the polarities, plus to plus, minus to minus. If we connect that in reverse polarity, there may be a chance of battery may get damaged or solar panel may get damaged. In order to protect that, we are using these 4 diodes as a polarity correctors. So when we are providing the input of in any direction, any polarity, the output of this rectifier is plus to plus and minus to minus, and this for only like any ripples generated while doing the polarity correction. This capacitor will remove the ripples and provide us a smooth constant DC of 12 volts. So that is input to the battery pack through these wires, and from these wires after the rectification and filtration from the transformer, and this is the main on off switch. When we on this, 12 volts DC input parallelly to the H-bridge circuits and again parallelly to this motherboard. But the operating voltage of our microcontroller is 5 volts. In order to make the 12 volts DC to 5 volts DC, we are making use of this 7805 regulator, the 12 volts DC input to this 7805 regulator, and the output is 5 volts DC output. So when we provide that, it starts producing the square wave pulse for this H-bridge circuits at a frequency of 50 Hz. And the same after this, the MOSFET circuit will provide us the 50 Hz of 12 volts AC with 1 amp current, and that will be step up to the 230 volts AC with help of this step up transformer, which is 12 to 230. Here we can see the two transformers. One is a step down transformer, 230 volts to 12 volts to charge a battery, and another is 12 volts to 230 volts step up for the inverting purpose. So coming to the ratings, we are using the 12 volt 5 watt solar panel and 12 volt 1 amp battery pack. This battery pack consists of 3 4 volt 1 amp batteries are in series, so we will get 12 volt 1 amp DC output. And yeah, this is the 230 volts to 12 volts 1 amp transformer, and this one is 12 volts to 230 volts 2 amp transformer. So let us see. So either the battery is charging through the transformer or solar panel, it will get fully charged in a duration of 6 hours minimum, 8 hours maximum. After that, automatically these diodes will block the current flow to protect the battery from overcharging. So keep the battery under full charge before demonstration of the project. Then after, I can disconnect the charging. And now when we on this, it will be on and off 2 times. Then the 50 Hz pulses will be given as input to the gates of this MOSFETs, and from there 12 volts AC will be generated after this H-bridge circuit, full bridge inverting circuits, and from there it step up to the 230 volts. So it will be around 190 volts to 240 volts. Based on the losses of the step up transformer, we may get the voltage in way. varying which is 190 to 240 volts AC output directly.